In the previous tutorial, we applied spectral analysis to the LRO4 Delta 18O benthic stack. And in doing so, we were able to identify dominant cycles at periods of about 100,000 years, 40,000 years, and 23,000 years. And these cycles correspond to orbital forcings. In this tutorial, we'll further explore approaches for assessing possible climate forcings and how they relate to variations observed in paleoclimate records. So on day one, when we talked about the intro to the climate system, we learned about a few different climate forcings. And just as a reminder, we'll quickly walk through some of the main climate forcings on Earth. Uh, for example, the greenhouse effect helps to regulate temperature. Incoming solar radiation has an important influence on global climate. And finally, as we've seen in the tutorials for this day as well, orbital cycles play an important role in Earth's climate. And in this tutorial, we'll specifically be focusing on identifying orbital forcings in paleoclimate data. So to briefly review the orbital cycles, there are three aspects that are part of the orbital cycles. First, there's eccentricity, which describes the shape of Earth's orbit and how elliptical it is. And this varies on a timescale of about 100,000 years. Next, there's obliquity, which describes the tilt of Earth's axis. And this varies on about a period of 41,000 years. And finally, there's precession, which is the wobble of Earth's axis. And this varies on a period of 21,000 years. So changes in orbital cycles drive changes in insolation, which is the incoming solar radiation. And this is the mechanism by which orbital cycles play a really important role in dictating Earth's climate. And these long-term variations in insolation can result in glacial interglacial cycles, as we've seen in previous tutorials. And shown here on the left are examples of the insolation component from precession, obliquity, eccentricity, and then all of the orbital forcings combined. And then on the bottom are variations in the climate state, specifically in glacial interglacial cycles. And just by visually looking at how all of these time series compare, you can start to notice some patterns and similarities. And this is something that we observed in the previous tutorial when applying spectral analysis to the LRO4 record. But there are also many other ways in which orbital cycles and variations in insolation can affect the climate system. And one example that we'll explore in the tutorial is the influence of insolation on monsoon intensity. So monsoons typically occur in the tropics and subtropics, and there are seasonal changes in the direction of the strongest wind. And these changes in wind are often accompanied by corresponding changes in precipitation. So what this produces is various wet and dry seasons in regions such as India, Southeast Asia, and East Africa, which have very strong monsoon systems. So how does a monsoon work? During present-day Northern Hemisphere summer, land is warmer than the ocean, so the winds blow from the ocean towards the land, and this results in increased rainfall over land. In contrast, during present-day Northern Hemisphere winter, the land is cooler than the ocean, so the winds blow away from the land. And this ends up resulting in increased rainfall over the ocean and drier conditions over the land. And this seasonal change in temperature and the difference in land-ocean heat contrast that causes the monsoons is primarily driven by seasonal changes in insolation. But on longer timescales, for example, on the order of tens of thousands of years, how do you think changes in land-ocean heat contrast would affect monsoon intensity? Would this have a similar influence as on seasonal variations? Well, in this tutorial, we'll look at a record of monsoon intensity over the past 400,000 years to try to assess the influence of orbital cycles and insolation on monsoon intensity on longer timescales. So the specific record that we'll be analyzing is a Delta 18O record measured on speleothems from Chinese caves in the Asian monsoon region. And with this record, we'll apply some of the data analysis tools that we learned about in the previous tutorials to try to assess the climate forcings of this record and determine if we see any influence of insolation and orbital cycles.